All right, we're continuing in our unit on advanced quadratics. And in order to continue from where we left off, we need to start learning about something called an imaginary number. An imaginary number. We're going to get to that by using this one simple question that hopefully we can answer really, really quickly. So we have this equation, we're going to solve it for x, right? And all this knowledge that we know from the previous units, well, this should be a piece of cake. It's already equal to 0. We can divide everything by 2, or we can, maybe we can solve using square roots and, all sorts of stuff. And that's what I want to do. I want to solve this using square roots. So I'm going to use all my previous knowledge and solve this thing using square roots. So what I'm going to do is subtract 48 from both sides. And so I have 2x squared equals negative 48. And then I'm going to get my x squared by itself because the whole goal, remember, is to leave a perfect square. I'm going to divide both sides by 2. And, all right, we're doing really well, and negative 48 divided by 2, of course, is negative 24. And then I'm going to take the square root of both sides. All right, so everything just like that previous unit, we're flying high. And so we have x equals plus or minus the square root of negative 24. And then you're thinking, wait, I need to get some 2 perfect square factors of negative 20. Hey, wait a minute. What the? That's a negative, a square root of a negative. What is going on here? I'm going to hit pause. Pause. Okay. I have a square root of a negative number. That is unreal. And seriously, it's unreal. Okay, this is not a real number. There's no such thing as the square root of a negative. So let me hit pause. I'm going to come back to that. Square root of a negative number. What in the world? So how do we deal with the square root of a negative? That's crazy. Now, this is where we have now just expanded our realm of numbers. So remember, so far, we have known everything about the real numbers. Right, the real numbers, we had rational and irrational, and we had integers and whole numbers and all sorts of stuff, natural numbers. Don't forget the irrational numbers. Those were our real numbers, right? So we were really comfortable with that. Now, what is the square root of a negative number? It's certainly not real because there's no such thing. And I'll give you an example. Okay, I'll give you an example. There's something you could probably wrap your head around. Here's an example. What's the square root of negative 4? Right? And of course, my clever students would say, well, that's 2 times negative 2. And I would say, hey, time out. Remember what the square root asks. The square root asks, what number times itself? What times itself? That's the key word. What times itself? Now, you can't tell me 2 and negative 2. That ain't itself. That's not the same thing. So don't tell me this is 2 and negative 2 because that's not what the square root asks. The square root of what number times itself. Okay, that's what the square root asks. So if you're looking at square root of negative 4, like, what? So we have to create this whole new realm of numbers. And we have to leave the real numbers and include something called imaginary numbers. So now we have imaginary numbers. And we're going to learn about the complex plane and all sorts of fun stuff later. But we have to get into the imaginary numbers. Now, the basis of the imaginary number is a good friend of ours, and we call him or her, I don't know the gender, but we call him or her I. I stands for this imaginary number. Now, the deal is, I has a value, okay? I has a value. So the value of I is actually the square root of negative 1. Okay, so since there's no, we can't take the square root of negative 1, that's the value of I. This is like this imaginary thing. And so when we take this concept of I and we apply it to other square roots, we can then start working with imaginary numbers. Okay, so remember how square roots work. If we have the square root of negative 4, what we're really looking at is the square root of 4 times the square root of negative 1. Okay, that's what this is. The square root of 4 times the square root of negative 1. So when I consider what my new friend I is, being the square root of negative 1, I can now know, well, hey, in this imaginary number system, I can now evaluate this thing. It's no longer no answer, right? We used to be no answer because we're looking in the real numbers. And that's why we would say no real answer, right? There is no real answer for this. However, there's an imaginary answer for it. And the imaginary answer is, well, the square root of 4 is 2. And the square root of negative 1 is our good friend I. So, in fact, the square root of negative 4 is equal to 2I. So what we can do is start using that concept to simplify a bunch of other expressions. And I'll give you another quick example, just a real fast one. If we had the square root of negative 16, okay, that would be the square root of 16 times the square root of negative, or the square root of 16 times the square root of negative 1. That would be 4I. All we have to do is account for our new friend, the square root of negative 1. And that's how that works. And we're going to get more into I in a second, not even in the next lesson. I'm going to jump into that in a second because I is just so much fun, so much fun. All right, so remember when I hit pause? Okay, now we're going to unpause. So we were solving the equation 2x squared equals negative 48. We divide by 2, and then we have plus or minus square root of negative 24. So we hit pause. Now we're going to unpause. Now we know we're going to be dealing with I. Okay, now we can simplify the square root of 24. Okay, so we know there is a perfect square factor of 24, and that's 4. Right? So we know we have 4 times 6 times negative 1. Notice what I'm doing here. Okay, I'm separating 24 into its perfect square factor, but I'm also taking account of that negative number because we're gonna be meeting our friend again, right? So all of this stuff is equal to x. Now, just like what we've done in the past, we have the square root of square root of 4, square root of 6, and the square root of negative 1. All right, so what does all this work out to be? Now, you have to be careful about format. Square root of 4 is 2, the square root of 6 is the square root of 6, and the square root of negative 1 is our friend I. Don't do this. Okay, we're going to get to this in later units, but don't do this. Okay, this is what we need to do. So what we have to do is write it in a certain format. We have to bring pretty much I becomes a coefficient. Okay, so we're going to take our new friend, put I as kind of the coefficient of the radical symbol. And so we have x being equal to plus or minus 2I times the square root of 6. And that is how we work with with imaginary numbers. Okay, so we actually have our solution set here. Two possible answers. There are two possible imaginary answers because we have now entered into the imaginary world of numbers. Okay, and I want to dig into that a little bit more right now because I'm going to ask a pretty cool question in the test. I just love it, love it. So here's the deal with I. We're going to remember some properties of I, right? Now, we know I. We just met him anyway, and we know I is the square root of negative 1. Okay? Now, if that's the case, what if I took I and raised it to the second power? What would that do? Well, we have to take a trip down memory lane. Remember, what is the square root of 2 times the square root of 2? Okay, so basically the square root of 2 squared. If the square root of 2 squared is equal to the square root of 2 times the square root of 2, which is equal to the square root of 4, which is equal to 2. Okay, we have to keep all of this stuff in mind, some basic stuff. This is then what it means. It means the square root of 2 squared is equal to 2. All right, now the same thing's going to happen with bigger numbers. What if I took the square root of 11 and I wanted to square it? That means I would have the square root of 11 times the square root of 11, which means I would have the square root of 121, which is 11. Oh, well, that's weird. Okay, so what does that mean? That means the square root of 11 to the second power is actually the number 11. All right, so what does that have to do with I squared? Now, if it's I squared, remember I is the square root of negative 1, so what is the square root of negative 1 squared? it's going to be equal to negative 1. Okay? Whoa, that's pretty interesting. So I squared is actually negative 1. Okay? Now, what if I had I to the third power? Well, if I had I to the third power, isn't I to the third power basically I squared times I? Isn't that I to the third power? Is it not I squared times I? Well, yes, it is. And isn't I squared negative 1? Why, yes, it is. And isn't negative 1 times I negative I? Why, yes, it is. So I to the third power is equal to negative I. Whoa, that's so cool. Then what would be I to the fourth power? Now we're thinking. I to the fourth power happens to be I squared times I squared. What? And I squared is negative 1. So negative 1 times negative 1 is positive 1. So I to the fourth power is positive 1. Whoa. Isn't that amazing? What happens next? What about I to the fifth power? This is going to be crazy. Isn't I to the fifth power I to the fourth power times I? Why, yes, it is. And isn't I to the fourth power 1? Why, yes, it is. And 1 times I is I. Wow. What about I to the sixth power? Let's keep going in this until we get crazy. Isn't I to the sixth power equal to I to the fourth power times I squared? And isn't I to the fourth power 1? And isn't I squared negative 1? And 1 times 1 is negative 1? So I to the sixth power is negative 1? What? Let's keep going. I to the seventh. Is I to the seventh not I to the fourth power times I to the third power? Why, yes, it is. Isn't I to the fourth power 1? Isn't I to the third power negative I? So I to the seventh power, negative I. Look what's going on. This is a neat thing. I to the eighth power. I to the fourth times I to the fourth. 1 times 1 is 1. So I to the ninth is I. I to the 10th is negative 1. I to the 11th, negative I. I to the 12th, 1. And it keeps going over and over. So I is a fun number to work with. Oh, I love it. So here's the question for you. What is I to the 58th power? Oh, wow. If we're going to evaluate that, well, you know what we need to know? How many 1s go in it? Okay, so look at where I numbers turn into 1s. I to the fourth is 1. I to the eighth is 1. I to the 12th is 1. Okay, so it's going in groups of 4. So basically, all we have to do is take 58, divide it by 4. Okay, 58 divided by 4 gives me, what is that, 14. And what's the remainder? Okay, so it's going to be 14 and a half. So it's basically 14 with a remainder of 2. And that remainder, okay, because it's cycling over every fourth time, that remainder of 2 means I to the 58th is the same exact thing as I squared. And I squared is negative 1. So I to the 58th power is negative 1. Wow. What if we had I to the 120th power? Okay, 120, totally divisible by 4. So you're looking at the same thing as I to the fourth power. And I to the fourth power is 1, so that equals 1. So there's just some fun stuff going on, and I love this so much. I get to ask a question on the test. So that's everything about I, and I just think it's fun. So we now have met and have worked with our good friend I, and we'll do more with that later. Thank you.